Hello, Algebra 2 folks. How we doing? Today is either March 7th or March 8th for you, depending on if you're A day or B day. Hello. We are reviewing Unit 7. Our test is next class period on the 9th/10th. So, I know it's not usually the norm of us doing the entire review together. But since one, I'm not there, and two, um, it's been a little bit for some of these things, right? Considering that they were done before the ACT. So I thought I'd give it, a good fair shot here and do as many problems for you as possible. Um, I'm gonna try to not be too slow, but I also don't want to just go too quick and you get nothing from this. But you will have the ability to rewatch this, so I'm gonna be somewhat quick so that way we can get through all of this. But also, so I'll try to be somewhere in the middle. Okay. So answer the following given the function. So you could very easily plot this into Desmos, but truly we should just look at this and realize h is this -5 moving us right 5 is our vertical asymptote, and this k value is our horizontal asymptote moving us up 2. Okay, that just needs to be pretty quick. All right. And then domain and range are directly affected by those asymptotes. The domain is affected by the vertical asymptote, so all real numbers except 5, and the range is directly affected by the horizontal asymptote, all real numbers except 2. Asymptotes tell us literally where the function does not exist, so we know that those are an exception. The particular values are an exception. Answer the following given the following graph. Okay, here's the graph below. Where is the vertical asymptote? The vertical asymptote is this line right here, this dotted line I just made. And that is at x equals 0. Yes, you will be marked wrong if you don't type x equals 0. The number of times, not to sound too sassy, but the number of times you're like, do I have to type the... Is there... I write x equals and y equals every single time I write the asymptotes. You should too. Horizontal asymptote is right here at -2. So this is y equals -2. And the domain and range, once again, is directly affected by those asymptotes. From left to right, my function exists everywhere except this one little spot at 0. And vertically speaking, my graph goes all the way up and all the way down, but it doesn't exist at this one little spot, and that's at -2. Okay. Back over here to 13. Rewrite 3x plus 5 over x plus 1 in the form AHK, then describe the graph of G as a transformation. So, there is a, let's say, algebraic way of doing this, but to be perfectly honest, I just prefer sort of figuring it out with Desmos. So if I type 3x plus 5 over x plus 1. When I type this, you can see, hopefully you can see, that there is a horizontal asymptote right here at 3 and a vertical asymptote right there at -1. Okay? That needs to be pretty visible to all of us. Okay? So, um, with that being said, if I were to rewrite this function with a, h, and k, well, my horizontal asymptote is affected by the k value. So if I type 3 here, you can see this purple function has a horizontal asymptote at 3 because I put one. Can you see that? Should I zoom in? I have 1 over x plus 3 here. So, but my vertical asymptote is different. Well, how do I change the vertical asymptote? By affecting the h. So I want a vertical asymptote at -1. So that means I'm going to have x plus 1 in the denominator. But you'll notice still they don't overlap perfectly. So I got the asymptotes to match. I don't have the stretch or shrink matching yet. Okay. So that means I need to tinker with this top value. What if I make it a 2? Right there. I found it. They're overlapping. You know? So I'm I'm looking at the original function and recognizing the asymptotes and then rewriting it with h and k so that way I'm forcing the same asymptotes. Plus 1 forces that vertical asymptote and plus 3 forces that horizontal asymptote. And then, you might not have chosen 2 right away. You might have chosen 3, and then you're like, oh, well, the bigger I get, the further it gets apart. So I need to shrink back down, and 2 is that magic number where it overlaps. Okay. So with that being said, y equals 2 over x plus 1 plus 3. And then it says to describe the transformation. Well, the 2 is a stretch. The plus 1 is a movement of left 1. And the plus 3 is a up 3. Okay. AHK. Once again, it asks us to do the same thing. So let's utilize that strategy once more. If I type my function x minus 1 over x plus 3, you can hopefully see here that there is a horizontal asymptote at 1. There it is. And there's a vertical asymptote at 3. Negative 3. Sorry, misspoke. Negative 3. Right? So if I moved up 1, that means there is a k value of plus 1. And look at that. The green function is now approaching that red horizontal asymptote because I moved it up 1. And I need to move it left 3, so that's plus 3. So I'm approaching the blue asymptote and the red asymptote. So I have my asymptotes correct, but my function is not anywhere in the same spot. First of all, they're in completely different quadrants. We got black here and here, and we got green here and here. Although my hands might be flipped, right, because of the camera. But hopefully you get the point. So if I want to flip it, I need to put a negative. Look at that. Now they're in the same spot. And clearly, the black function is stretched out further. So again, we just tinker. Is it a 2? Is it a 3? Is it a 4? Is it a 5? I think you just saw it, right? It was 4. So negative 4 over x plus 3 plus 1. So I'm going to go ahead and write that down as well. All right. So what happened here was a flip and a stretch and a left 3 and an up 1. Far so good with the graphs. That's the last graphing problem, I think. All right, so now we're multiplying rational expressions. So we were graphing rational expressions just now, and we're going to multiply rational expressions. So when multiplying, you just want to factor and cancel out the terms that are the same, and then multiply them all together, whatever remains after canceling out the factors that are the same. So factoring the numerator here, what multiplies to negative 4 and adds to negative 3? Um, I still like when this is just me going on a slight tangent, but there are still moments where someone asks a question on how to factor, or um, I ask someone to just answer it for me, and we're still deliberating over what to choose. But I'm not just pulling the numbers out of thin air. There are a very limited number of options that multiply to the number 4. 1 and 4, 2 and 2. That's it. Those are the only two numbers that multiply to 4. So how can you adjust them to make it positive and negative, so that way it adds to -3. Well, if you make it a -4 and a +1, -4 plus 1 is -3, and -4 times 1 is -4. I'm not just like racking my brain like just today. The reason why I'm saying is just today I asked someone to factor something for me, and like it took too long. And I'm glad that they tried it. I'm glad that we got to the right answer, but it took too long. So there's a limited number of options. You need to realize that. Very limited number of options. Looking at the next one, what multiplies to 18? 1 and 18, of course. 2 and 9, because it's divisible by 2, it's even. And then 3 and 6. That's it. There's only 3 options. And it needs to add to -3. But think about this. If you have 1 and 18, 1 and 18 are way too far apart. How is 18 minus 1 going to possibly be 3? You know that the digits need to be close to each other, right? Does that make sense? Like 9 minus 2 is 7. It still doesn't get you to 3. It's the 6 and the 3, or 6 and 3 are close to each other on the number line. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But 2 and 9, 2, 3, 4, 5, 6, 7, 8, 9, they're too far apart. I know that, I don't know how big of a crowd I'm talking to right now, right? But just think about those two numbers. If they're trying to add to -3, they need to be close together. -6, +3, or adds to be -3. -6 times 3 multiplies to be -18. So, what factors are the same? This one with this one with this one, and you're left with, boom, the following. Okay? All right. Continuing on, find the product. Let's do it again. There's a GCF this time around. They're both divisible by 2, and they share an x. What multiplies to 6 and adds to -7? They both share a 3, and there's that. Okay? So cancel out what is the same. Boom, 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 boom. I'm literally just left with 3. That's the final answer. Okay. Division. Dividing is the same thing as multiply, but by the reciprocal. So when I see this, we're going to divide, aka multiply by the reciprocal. So they have a GCF of x, and I'm left with 3x plus 5. And this problem is a little more difficult than some of the ones that we did, but I'm going to go ahead and do it anywho. The a value is not 1. This is where we split the middle term back in the day, right? It's been a while since I said that phrase, but what did I do? I did the front times the back, 6 times 15, and that equals 90. So then I figure out what two numbers multiply to 90 and add to -90, sorry, because it's -15, and add to 1, the middle term. So I'm just going to do this work off to the side. So what two numbers multiply to -90 and add to 1? Again, if they're going to add to -1, or 1, sorry, they need to be close together. 10 and 9. 10 times 9 is 90. So we split the middle term with those two numbers. You remember doing this? Because we did. We did it many a time, actually. We split the middle term with 10 and -9, and then you group. You look at the first two. The GCF of the first two is 2x, and I'm left with 3x plus 5. And then you look at the GCF of the next two, that's -3, and I'm left with 3x plus 5. So in the end, the factored form is the two terms that we pulled out and the term that matched. Remember doing that? I mean, that's a good problem. That's a good skill to still hold on to. So with that being said, we see that these are alike, and really that's it. So 2x minus 3 on top. And because we have an x squared and then an additional x, I'm going to go ahead and write that as 4x cubed because I'm multiplying them together to just combine them as 4x cubed. All right. Find the quotient. I don't know if I'm going too quick or too slow. I wish you could let me know, but you can't. But there's a lot of factoring on this one, so let me maybe go especially slow on this one in case I lost you on any of the factoring. I really want you to feel comfortable with the factoring. So, what multiplies to negative 40 and adds to negative 3? Again, a small number, so they need to be close together. 8 times 5 is 40. 8 minus 5 is 3. Boom. And what multiplies to negative 20 and adds to 8? 8, a bigger number. The numbers need to be a little further apart. 10 and 2. 10 times 2 is 20. So is 4 and 5, but I don't care. 10 and 2. 10 minus 2 is 8. Multiply by the reciprocal. So I'm actually looking at this right now as I start to write the numerator. I'm looking at this one first. What multiplies to 20 and adds to 12? Again, a big number. 10 and 2, except it's interesting. They're both positive now, right? Same numbers, but they're both positive. I like that. This is really showcasing how that can make a difference. So both positive. And 13 for 40. What a great problem. 8 and 5 once again, except they're both positive. I really like this problem. So we're multiplying by the reciprocal, and we can cancel out some things. This with this, and this with this. And in the end, we're left with x minus 8 times x plus 2 all over x minus 2 times x plus 8. You might be tempted to want to cancel those things out, but the factors need to be identical. So, not happening. That's the end. Okay. 19. Find the sum. So we're moving on from multiplication and division. Okay. Hopefully those are some good examples there, and you can always go back and rewatch this video. It will be posted. It is posted. That's how you're watching this in the first place, right? It is. We're on YouTube right now. So find the sum. What's the important thing about finding the sum? A common denominator. Okay. I think simplifying, multiplying, dividing, to me, these problems, the only challenging part is, don't mess up the factoring. After that, recognizing what's the same and just canceling, I mean, what an easy skill, right? It's just, oh, they're the same. Bye bye. But getting a common denominator definitely requires a little more subtlety. So we definitely have to factor here. This factors into x plus 6, x minus 1. But that allows us to realize that, okay, when looking at these other two terms, I am missing x plus 6. And when I say missing, I mean I'm trying to get a common denominator. They need to be identical. And this is missing the x minus 1. So if I multiply by that, um, then I'll have a common denominator. Now, I'd like for you to understand why this is legal, why this is allowed. I don't want you to just memorize the process. I want this to be like, yeah, like this makes sense. Why is this allowed? Why is this legal? Because we're multiplying by the number 1. When I take 5 and multiply it by 1, does that change anything? No, the answer is 5. If I multiply by 2 over 2, does that change anything? I get 10 over 2, but guess what? That's still 5. It's just a different way of multiplying by the number 1. I could multiply by x over x. But guess what? I'm going to get 5x over x, and the x's just cancel, and I'm left with 5. So by multiplying by 1, I'm not changing anything. I'm simply changing the appearance. 10 over 2, 15 over 3, they're all the same thing. They're 5. So by multiplying by this, I'm just changing the appearance of this fraction. So I'm going to do good old box method here. And get x squared plus 8x plus 12 all over x plus 6 times x minus 1. You with me on that? I box method these together and then just kept the denominator as it is. Now you might be wondering, well, why don't you multiply the denominator together, box method style? It's just to save us some time, okay? We need to have this multiplied together so that way in the end here we're going to be combining like terms. We don't combine like terms in the numerator, or sorry, in the denominator, right? So let's go ahead and multiply by 2 here. We end up with 2x minus 2 all over x plus 6, x minus 1. And then the 14 all over x plus 6 times x minus 1. Like I said, we're about to combine like terms. We have a lonesome x squared, but then we have an 8x with a 2x. So that's 10x. And then we have a 12 with a negative 2. 12 minus 2 is 10, but then plus 14 is 24. Now, when you get to the end here, it's always wise to do a double take and go, now that I have multiplied this stuff together, now that I have combined like terms, is there anything else I can do? Can I factor any further? So take a look at 10x and 24. What multiplies to 24 and adds to 10? A lot of times, nothing will work out. But we're getting lucky here. After all that addition, it actually turns out to be factorable into x plus 6, x plus 4. Because x plus 6 times 4 is 24, and 6 plus 4 is 10. And when you know it, they share a term, and in the end, we get x plus 4 over x minus 1. And that is the final answer. Gotta love it, right? Gotta love it. Good problem. Good problem. Finding the sum. I think we're making good time here. We're only 23 minutes in, and we have 1, 2, 3, 4, 5, 6, 7 problems left. I think we're making good time. These are going to slow us down though, but I think we'll be okay. So just factoring really quickly, I'm maybe starting right now. I'm gonna spend less time factoring. Right, I kind of elaborated on those first few, but now it's just like okay, let's start to recognize. Okay, how do we factor? What are we doing? So what are we missing here? We need an x plus 3 on this, and we just simply need that 12 on this one for them to match. All right. 12 x minus 4 x plus 3, 12 x minus 4 x plus 3. They match now. Let's multiply these together. 12x over 12 times x minus 4 times x plus 3 plus 5x plus 15 over 12 times x minus 3. Combine like terms, the 12x and the 5x make 17x plus 15 all over 12 times x minus 4, x plus 3. Is there a GCF for 17 and 15 that we can factor out? No. Is there anything in common as we're staring at it right now? No. We're done. That's it. Find the difference. Same thing as addition and subtraction. It's just that, well, when you subtract, You just need to be careful that you're subtracting each and every term. So this denominator needs a minus 5 as well to have them in common. So we'll go ahead and multiply that in. And we end up with 2x minus 10 all over x plus 5 times x minus 5. So when I said make sure to subtract each and every term, what I mean by that is 3x minus 2x is x, and negative 5 minus negative 10 plus 10. So negative 5 plus 10, because you're subtracting the negative, gives me 5, x plus 5, all over x minus 5, x plus 5. And would you look at that, they cancel out. The x plus 5 and the x plus 5, leaving me with 1 over x minus 5. Not a 0. Tempting because you're like, there's nothing there, right? There's a 1 there, right? It's invisible. Okay. Um, Last subtraction one here. Find the difference. Nothing alike about these denominators, so we need to multiply by x minus 4. There's no factoring to do, so that's nice. Makes the problem a little quicker. And when we distribute the x, we get x squared plus 2x. And when we distribute the 2, we get 2x minus 8. And now when we subtract each term, we get x squared, and then 2x minus 2x canceled out. X squared minus negative 8 means plus 8. So x squared plus 8 all over x times x minus 4. And that's it. Because x squared plus 8 doesn't factor into anything. I mean, you can just ask yourself what multiplies to 8 and adds to nothing. That's impossible. You can't multiply to 8 and add to nothing. So, 4 and 2, that's it, right? 4 and 2, or 1 and 8, but still, you're not going to get 0. So, yeah, that's it. You can't factor that. All right. The last few, two complex fractions and two solving ones. Let's do the solving first. So when solving equations, um, there's this, you know, situation where, we just had this lesson, 7.5. That was our latest lesson. And we recognize that if the denominator is the same, then you could just focus on the numerator. So if you can make the denominator the same, sort of like adding and subtracting, then you just focus on the numerators. Sort of like I probably said this in class, but if I dare to compare it to like exponent problems, you remember these types of problems, right? Something like that. If we can make the base the same, now we can just focus on the exponents. It's a very similar strategy. If we can make the denominators the same, if we can get a common denominator, then we can simply focus on the numerator. Okay? If we can get a common denominator, we can just focus on the numerators. So with that being said, that's 8x plus 24, and that's 5x minus 15. And notice I'm totally scrapping the denominators. I'm done. That is my equation. Once we get a common denominator, we can just focus on the numerators and solve. X equals negative 13. Let's do it again with multiple terms or multiple, yeah, terms, expressions, maybe, if you will. So we factor this up because it can be, and we can recognize that, okay, it has both ingredients, you might say. It has the x plus 4 and the x minus 2. This one's missing a minus 2, and this is missing a plus 4. We can multiply those together. 6x plus 24, just distributing. And then, so like I said, we can just focus on the numerators. But when I focus on the numerators, I can't ignore this subtraction. So yes, I got a common denominator. Yes, I can just focus on the numerator. But when I say focus on the numerator, we still can't forget what's happening in the problem. Okay, so that's changing to minus 6x plus 1, and boom, there's my equation. So the 6x's are actually canceling, 6x minus 6x, and 24 and 1 adds to 25. Add the 10, you get 35. Divide the 5, you get 7. So this is subtle, but very important because all of a sudden you're gonna have like 12x plus 25 or something like that if you forget this minus. So yeah. This problem asks us to state the excluded values. This is the first time we're doing this, but that's okay. Excluded values are whatever makes the denominator 0. So I would be excluding 2 and negative 4. And then state the least common denominator. Well, that's literally what we found. Okay, so don't overthink that. Like we found the least common denominator. So just write it down. All right, last two, the complex fractions. We're going to be on 40 minutes. Um, During this class period, at some point, maybe you did it at the beginning, or maybe you're about to do it after this video. But there is the, just so I don't forget this thought, there is the 7-4 and 7-5 quiz. That is the second to last summative for core three. So we have the 7-2, 7-3 quiz, which you're welcome to retake if you have that left. 7-4, 7-5 is what we're doing today. You can retake that again sometime as well before the test, come next class period. And then we have the test, of course, which is our big summative. And that'll cap us out for quarter three. But okay, here we go. Let's simplify this complex fraction. Focus on these pieces individually. Okay? So I like to focus on them one at a time. So here's the numerator and here's the denominator. Get a common denominator for this little piece here. Get a common denominator here. And add those together. So we've addressed the numerator. We've addressed the denominator. So I just turned this into this. Because I combined these together into this, and I combined these together into this. So what's so great about that? Well, that's because we can now divide, aka multiply by the reciprocal. So we're multiplying by the reciprocal, and we end up getting x squared minus 18x over 30x plus 12. End story. There it is. So we took this complex fraction and turned it into this. All right, last one. Simplify the complex fraction. Well, luckily we don't really have to do anything to the numerator. I can at least factor it, this bottom half of it. So that's plus 5 minus 4. Okay? But I do need to address the situation that is the denominator. Let's get a common. So I know I'm saying the word denominator twice. I'm looking, there's one big fraction with a numerator and a denominator, but then when I look at the bottom half, there are also fractions there, and I need to get a common denominator as far as those are concerned. Okay, as far as the bottom half is concerned here. So I end up getting 2x minus 8 over x minus 4 times x plus 5. And then I end up getting x plus 5 over x minus 4 times x plus 5. And then when I add those two things together, I get 3x, and negative 8 plus 5 is negative 3 all over x minus 4 times plus 5. So this is this. So with that being said, we are dividing, aka multiplying by the reciprocal. And there's that, right? I hope I didn't lose you. This barely changed. This turned into this. So I'm taking this and dividing it by this, aka multiplying by the reciprocal. There is some canceling and some factoring to do. So this right here can factor into 3 times x minus 1. And 9 is the same thing as 3 times 3. Clearly, this is the same as that, and this is the same as that. But we can also cancel out a single 3, and we're left with 1 3 in the numerator and x minus 1 in the denominator. What a beautiful world we live in. We're under 40 minutes. What a fabulous world to be in. I want to real quickly pull up the online review. And just skim it to see if there was any other items that I put in there that wasn't on this written part. Sorry, I should have had this pulled up already. My apologies. So, here's the review. Okay, we did that. 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 Just more of the same here. We did that. We did that. We did that. Just did that. We did that. All right, no surprises. Okay, so I feel good about that. Um, I apologize that there was a little bit of a lull here at the end. I should have just been a little more prepared there, but I'm just doing this slightly on the fly. So I will see you next class, of course, for the test, and I think I should be able to stream Tuesday night. Like I'm absent right now. If you're watching this on a B day on Tuesday, but that's because I'm getting back into town on Tuesday, and I'm feeling up for it. It just depends on how tired I am, to be honest. Um, I will do a stream that night, and we could maybe focus only on the online portion if you want to throw problems at me, because these are randomized. So you can throw more specific questions at me from the online. This video you can go back. I'm sorry, I'm making this end portion long, but this video you can go back and look at on your own time here, coming up into the test. Please make this test count. I mean, every test counts, but this one, it's right here at the end of the quarter. It can make a difference for you. There's really not an opportunity to retake, and that's not me trying to be cruel. It's just the way the cookie crumbles, okay? So make this attempt count, right? The quarter ends. I have to submit. It is what it is. So, um, make it count. Study up, talk to a friend, study together, right? You got to know somebody, right? FaceTime each other, do some problems together. Um, yeah. So with that, there should be some time still remaining. I encourage you to do the online review. I encourage you to press submit and see which ones you got wrong. It will reveal the answers and everything. So yeah, just do your best and enjoy the rest of the class period. And I will catch you later. All right. Appreciate you. And until next time.